Assalamu alaikum dear student. Today we are going to solve this past paper 507011 and it's made on 2018. This is a multiple choice question and it has 40 marks and time is 1 hour. Okay, so let's move towards the first question. A gas is less dense than air and soluble in water. Gas is less dense than air and dissolves in water. When it dissolves in water, we cannot remove it with a water displacement. Okay, but less dense. So when it is less dense than air, so it will be moving upward. So by upward delivery, it will be collected. It's not possible for the this is more dense than air. Okay, and here you can see that it is going up less dense than air by upward delivery. It is the answer. This is displacement of water. Now it dissolves in water, so how would it be able to escape? Okay, and here is it's not suitable. Okay, option B is correct. Which mixture can be separated into its components by adding water, stirring and filtering? Means when we add water, so out of the two components which are provided, one should be soluble and one should be insoluble, so that we may stir and filter. The soluble will become aqueous solution, will go down as filtrate, and insoluble will remain as residue. When you look on the calcium carbonate, it is insoluble, and sodium chloride, it is soluble. So it's possible. Okay, this is the answer, because this will not dissolve and this will be dissolved, so it will be its aqueous solution will be filtrate and this will be residue. Okay, magnesium and iron both are insoluble. Sodium chloride and copper sulfate both are soluble. Sulfuric acid and hydrochloric acid both are soluble. Question number 3. Tests were carried out in an aqueous solution of an unknown compound. The observations are recorded in the table. So what is the test? Let's see. Aqueous sodium hydroxide added green precipitate soluble in excess, giving a green solution. When there is green solution, you must know that there is Fe plus 2 ion. When you add dilute nitric acid and then aqueous barium nitrate, so white precipitate is formed. What it shows that this is confirming that its cation is iron. That's what is giving the green precipitate. Okay, so when we add nitric acid, this act as the catalyst. Okay, it increases the rate of reaction. You can say that it actually reacts with the impurities. So the barium nitrate, when it reacts, so white precipitate is formed. So which anion will be there which makes with the barium white precipitate? Actually, it should be barium sulfate. Okay, so barium sulfate is insoluble, so it means it is confirming SO4 minus 2. Now let's see. Dilute nitric acid added, then aqueous silver nitrate, no precipitate. Okay, when we add aqueous silver nitrate, so no reaction. So here the sulfate ion is confirmed. Okay, it's not chloride. Okay, so what is chromium? No, iron plus 2 is confirmed. Okay, so it will be chlorine. No, if there is chlorine, so sodium nitrate, when it was added, so silver nitrate, so silver chloride had to form the white precipitate, but no precipitate found. It confirms that there is no chloride ions. So with the barium sulfate reacts to form the insoluble barium sulfate, white precipitate is formed. So actually here the chloride ion is rejected, sulfate ion is confirmed, and iron ion is also confirmed. So option D is correct. Which substance would diffuse more quickly? Okay, both have been given different temperatures. We'll look towards temperature, but first we'll go towards their molecular masses. It has 44 and it has 10 mass, sorry, 20 mass. Okay, 10 is its atomic number. So definitely they have the more molecular masses, they will diffuse slowly. Now out of these two which have the molecular masses, okay, so which will diffuse first, the one which has the high temperature, because you know that increase in temperature increase the rate of diffusion, and decrease in the molecular mass also increase the rate of diffusion. So D option is correct. The ion Q plus 2 has a 3 complete shell of electrons. What is Q? Okay, when we have three complete shells, so first shell we are talking about Q plus 2, okay, it has 3, 2, 8 and 8. So actually it removed 2 electrons, that's why it became the Q plus 2. When it gains 2 electrons, so it will be Q. So now I'm adding here 2 electrons as well. Okay, here is the 2, 8 and 8. That's why it has plus 2 charge. When 2 electrons are added, so it becomes Q. So basically Q is 2, 8, 8 and 2. It becomes calcium. Okay. Question number 6. The diagram shows the arrangement of the particles in 3 solids X, Y and Z. The solids are krypton, potassium and sodium chloride. You must know what is a krypton. Krypton is non-metal, okay? Potassium is metal, it will have metallic bond, okay? And sodium chloride is a ionic compound. Okay, so this can be NaCl because it is in the crystalline form. Na plus and Cl minus are arranged in the 3D form. Okay, this can be metal, which is the potassium K. This is the atoms which do not form the metallic bond, and brittle as well. So these are the non-metals which have the weaker intermolecular forces. So which non-metal is there? Krypton. So X should be sodium chloride, not krypton. Okay, out of these two. Then second should be potassium. Y should be potassium. This is the correct option. And third should be krypton. Okay, so option D is correct. In the electrolysis of copper sulfate aqueous, what is the ionic equation for the reaction at cathode? You must know that in the copper there is Cu plus 2 and SO4 minus 2. And because it is ionic, it is aqueous, so it will have the H plus and OH minus as well. Okay, so what will happen at the cathode? Cathode is the one on which the reduction takes place, Cr. Okay, and cathode itself has a negative charge, so cations will negative charge. Okay. So cations will be attracted. Cations will be attracted. So out of these two, the ability to be discharged for the copper will be greater. So copper will be discharged. Okay. So what will happen? Copper will gain 2 electrons. Gain of electron is called reduction, and it will become copper solid. Okay. This is the aqueous. So simply copper gains 2 electron and copper plus 2. No. By gain of electron, how it becomes copper plus 2? Strong. Plus 2 gains 2 electrons, it becomes copper. Yes, this is correct. These reactions do not take place. Okay. Ethane, C2H6 and ammonia, NH3 are covalent compounds. The dot and cross diagram of these compounds are shown. Okay, so you can see that dot and cross, this is the ethane and this is the NH3 ammonia. These statements are correct. A compound of ethane contains twice as many hydrogen atoms as molecule of ammonia. Ethane has the twice as many hydrogen atoms as the ammonia. Ammonia has 3 atoms and it has 6 atoms. So it has the twice number of the hydrogen atoms as compared to the ammonia. This is correct option. An unreacted nitrogen atom has 5 outer electrons. Unreacted nitrogen atom, yes. When we have nitrogen which has not reacted, so it has 2 and 5. Outermost it has 5 electrons. It's okay. In a molecule of ethane, the bond between the carbon atom is formed by the sharing of two electrons, one from each carbon. Yes, each carbon is sharing one electron. In this way, overall two electrons are shared. So that's why, because it is ethane alkane, so only one single bond is formed. Okay, only one bond is formed. So by sharing of two electrons, each from one carbon. So this is also correct. So option A is correct. Okay, 1, 2, and 3, all these statements are correct. Okay. This statement is correct. All compounds are ionic. All compounds conduct electricity when are molten. All compounds are not ionic. Some are covalent as well. All compounds conduct electricity when molten. No. Some compounds which are not ionic, even if those are molten, but they do not conduct electricity because they don't have ions. Each element only contains one type of atom. Yeah, this is correct because when we have C6, it means the six atoms of there of carbon, but all are same. We write O3, three atoms are there of oxygen. This molecule will be known ozone, but it has the three atoms of oxygen. All are same. In a mixture of substance, the proportions of the substances are always same. No, they do not have fixed proportions. This is also wrong. When one volume of the gas R reacts with 5 volume of oxygen, it forms carbon dioxide and water only. Now let's try it out. Plus O2. You must know that these are all hydrocarbons. Okay. So when they react with the oxygen, they form the carbon dioxide and the water. Okay. So now let's see one volume of which gas consumes the 5 volume of the oxygen. Now let's see 4 carbon dioxide. Okay, all the carbon will be converted into the carbon dioxide. 10 hydrogen, so it will become 5H2O. 4 twos are 8 and 5 ones are 5. 8 plus 5, it becomes 13. So 6.5 comes here. It's not 5. Okay. Ethane plus O2 I'm writing here. What will happen? 2 carbon will be converted into 2 carbon dioxide and 6H2O. It means, sorry, 6 hydrogen, so it will form 3H2O. 6 hydrogen. Okay. So 2 twos are 4 and 3 ones are 3. 4 plus 3 7. So here it should come 3.5. Methane CH4. I'm writing here O2. Carbon will react with oxygen to form carbon dioxide. There is only one carbon and hydrogen are 4, so it will form 2H2O. Okay, so 1 twos are 2 and 2 ones are 2. 2 plus 2, it becomes 4. So 2H2, 2 twos are 4. This is also incorrect. Now we have last option O2. If it reacts, 3 carbon will become 3 carbon dioxide and 8 hydrogen will become 4H2. 8 hydrogen and oxygen. Okay, 3 twos are 6 and 4 ones are 4. 6 plus 4, it becomes 10. So 5O2, 5 twos are 10. So 5 volume are consumed when 1 mole of or 1 volume of the propane reacts. Option D is correct. Two characteristics of G are given. G reduces copper oxide to pink brown solid. Reduces means the loss of oxygen. Okay. 1.4 loss of oxygen. Okay, it should be clear. So by looking at the first, which will be able to reduce. Nitrogen won't be able to reduce because it reacts at a specific temperature with oxygen. Okay, that's impossible over here. That's very hard. Okay, at local, almost impossible. Now let's see, 1.4 gram of G, that means out of these gases, which is oxidizing agent and reducing agent. Okay, reduces other and itself is oxidized, has the volume of 1.2 dm cube at room temperature. Now let me tell you that mole and volume. If sorry, I'm writing here mass and volume. If we have 1.4 gram, the volume will be 1.2 dm cube. But if we have 24 dm cube, what will be the volume? Because 24 contains 1 mole dm cube. Okay, so in this way, and the mass will be increased, it will be the molar mass. So what we get, 1.2x is equal to 1.4 multiplied 24, x is equal to 1.4 multiplied by 24 divided by 1.2. We'll have to use calculator over here. After using calculator, we'll find that it's x is equal to 28. So 28 is the mass of nitrogen as well, but it will not react. Hydrogen has 2 mass. No, it's not possible. Nitrogen, 14 plus 16, it becomes 30. 30, okay? It's also not possible. Carbon has 12 plus oxygen has 16, it becomes 28, yes. And it can oxidize. It can be oxidized, and it is acting as the reducing agent. Okay, it can reduce the copper oxide into the copper pink solid. The relative formula mass of 4 compounds are given. A student has 1.0 gram sample of each compound. Okay, all compounds have 1 gram of each. Okay, and their relative formula masses are also given. We find out their number of moles. How? One given mass divided by their molar mass 102 is equal to number of moles. Okay, so is equal to 1 by 80 is n is equal to 1 by 98, n is equal to 1 by 63. So what we get here some quantity. Okay, so we'll have to use calculator over here. One divided by 102, it becomes 0.0098, and then 1 divided by 80, it becomes 0.0125, then 1 divided by 98, it becomes 0.010, and 1 divided by 63, it becomes 0.015. Now, because this is number of moles, and if one mole contains 3 oxygen, so we will multiply with the 3 because we have to find oxygen atoms. Okay, moles of oxygen atoms. 1 mole contains 3 oxygen atoms. Okay, 1 mole contains multiply 1, multiply 4, and multiply 3. So it will be 0.047 is equal to 0.040 is equal to 0.0125 as it is. It is equal to 0.0098 multiplied 3 equals 0.0294, which is the higher quantity here. It contains the high number of oxygen atoms. Okay, so option D is correct. Okay, the next question is, diagram shows the electrolysis experiment using inert electrodes, the electrodes which do not react. Okay, so what could be Y? Okay, let me minimize a bit. What could be Y? Y means electrolyte. What could be? If there is copper sulfate, how would we know that this is the before electrolysis, that there is no oxygen, there is no any gas? Okay, when after electrolysis, you will find that on the negative electrode, which is called cathode, the volume of oxygen is twice almost. of the volume of the, so volume of any gas is twice as compared to the volume of the gas on the anode. Okay, so it means in both cases gases are produced. So now let's find out. Okay, in copper sulfate solution, copper plus 2, SO4 minus 2, H plus, and OH minus. At cathode, okay, uh, which has a negative charge, copper will be discharged instead of hydrogen. Okay, so there is no gas produced, so it can never be. Means if gas is produced on the anode, it's okay, but on the cathode there is no gas produced, so that's why it can never be an option. Consider aqueous sodium chloride. Sodium chloride, H plus, OH minus. This is about water. Na plus and Cl minus. It's okay here because when cation is compared, so then hydrogen is preferred. 2 hydrogen plus gains 2 electrons, it will become at the cathode H2. It's okay. When the chlorine is there, so 2 chloride ions will form the chlorine molecule and 2 electrons will be replaced. So you see their volume is equal. Both gases are produced, but the volumes are equal. So this can also be not part of that. Okay. Dilute sulfuric acid. What is dilute sulfuric acid? Let me write here. Dilute sulfuric acid contains 2H plus and SO4 minus 2. And then water itself contains H plus and OH minus. Okay. So now let's see what happens. It has higher amount of the hydrogen, which will move towards the cathode. So suppose we have 4H plus and 4OH minus. Okay, this will never be discharged on the anode. So now let's write first of the anode, 4OH. This is the very famous equation. 4 electrons will be released, 2H2O water will be found there, which is the liquid, and O2 gas will be released. Okay, so this is one time. And when we see here 4 plus 2, it becomes 6 hydrogen plus 6 electrons, then 3H2O, so it will be formed. So it means the hydrogen which is formed on the cathode, okay, will be greater in the volume as compared to the oxygen formed on the anode. Okay, so here oxygen is formed, here hydrogen is formed. Okay, so H2SO4 is the option, and ethanol is not electrolyte. This is the option, correct option. Which statement about the ionic compounds is correct? Ionic compound connect electricity when solid because they contain the charged particles that can move. In case of solid, they cannot conduct electricity. Okay, because the charged particles cannot move. Ionic compounds consist of letters of positive and negative ions. Yes, this is the correct option. If they have the letters of positive and negative. Most ionic compounds are solids at room temperature. No, not most. All of the ionic compounds are solid. When molten or in aqueous, ionic compounds conduct electricity because they contain electrons. No, they conduct electricity when the molten and the aqueous form, but they don't have electrons. They have the free ions. Okay, so B option is correct. The diagram shows apparatus that can be used to extract aluminum from the ore. We can see here what is here. So what is the J? J is a anode. Okay, actually this is aluminum oxide, Al2O3. This is used, so it forms 2Al plus 3 plus 3O minus 2. Simply I'm just telling. Okay, so aluminum has to be removed from here, okay, in the liquid form. So that's why cathode can never be over there. Cathode has to be here. So what it would be? It will be anode. It will have positive charge, okay, to attract oxygen so that it will be removed, okay, from here, and the cathode has to be here. Okay. But now let's see what is here. which thing moves from here? L is the aluminium. Okay, and K is the aluminum oxide is used, Al2O3, and plus cryolite. What is cryolite? Because to remove, to decrease its melting point. Okay, so that's why it is used, cryolite. So from where the aluminum are taken here by the cathode and oxide are taken upward, go up. Okay, so you can see that J can never be negative electrode. Okay, positive electrode, it's okay. It is only aluminum oxide, no, it has the cryolite as well. Okay, and then what is removed here, that is aluminum is removed here in the molten form. Okay, not cryolite is removed. Okay, cryolite remains as it is over here. It is used for some other purposes. Okay, to minimize the melting point, so that melting point of the aluminum oxide. Positive electrode is this one. This is aluminum molten, aluminum oxide and plus cryolite. The diagram shows energy profile for a reaction. The statement about this reaction is correct. More energy is needed to break the bonds than is released when new bonds are formed. No, not more energy is taken. Okay? Because it's exothermic, less energy is used and more is released. It is not arrow in this way. Actually, the arrow is in this form. Okay? Not correct. The root 1 and root 2 give the same overall equation for the reaction. Yes, root 1 and root 2 both have the same overall equation. It's okay. Root 2 involves the use of catalyst. Yeah, it's okay because the alternative pathway is given where the activation energy is decreased. This is because of the use of catalyst. It's okay. The reaction is exothermic. It's okay because reactants are at higher energy level than the products. So definitely energy has to be released. It shows the exothermic reaction. So 2, 3 and 4. 2, 3 and 4. Option C is correct. Okay. To see all this question, I will have to minimize it. Okay. What is the question? The question is, the diagram shows the fractionation of petroleum, means the crude oil fractional distillation takes place. Okay, so fractions are given here. Crude oil is heated up to the 400 centigrade. Okay, so fraction and their uses. Bitumen as lubricant. Bitumen as lubricant? No, not at all. This is not used as lubricant. Okay. Okay, diesel as aircraft engine. In aircraft engine, diesel is not used. Petrol, something like that, or kerosene, but not diesel. Diesel is used for motor engines. Okay, naphtha for making road surfaces. How naphtha can be used for road surfaces? No, that is not naphtha. Okay, so naphtha is not used for the making the road surfaces. Okay. Then paraffin or kerosene, जिसको मिट्टी का तेल कहते हैं, means the used for heating and cooking. Yes, this is the option. That is the correct. Which compound is constituent of petroleum crude oil? It has to be alkane. It is alcohol? No. It is ethanoic acid, carboxylic acid? No. C8H more 2 more than its number of carbons. 16 plus 2, 18. Yes. C6H12O6. This is a carbohydrate. It is not found over there. So alkane is found. What is alkane? CnH2n plus 2. Hydrogen has to be 2 more than the double. 2n means double of the carbon atoms, number of carbon atoms. Okay, the hydrogen will be double of this, and then plus 2 means 2 more than the double. So double becomes 16 plus 2 18. This is the alkane. A student wrote two conclusions about the calcium carbonate. The conclusion: the reaction with the dilute hydrochloric acid is faster with the powdered calcium carbonate with large piece. The reaction with dilute hydrochloric acid is faster with powdered calcium carbonate than the large piece of the calcium carbonate. If you take that in powdered form, so it will be faster. Okay, it will be faster with the powdered calcium carbonate. Okay, the grinding large piece of the calcium carbonate to form the powder increases the surface area. It's okay. Actually, this is explaining the first one. First one is just a statement that with the powdered calcium carbonate, reaction of hydrochloric acid is faster as compared to the large piece of the. And second is explaining the first one that actually when the powder is formed, so surface area is increased. Both conclusions are correct. It's okay. The conclusion 2 explains the conclusion 1. This is the correct. Okay. Both conclusions are correct, but conclusion 2 does not explain. No. It is explaining, it's telling the reason why powdered calcium carbonate has the first reaction. No. Conclusion 1 is correct, but 2 is not correct. How 2 is not correct? It's also correct. Conclusion 2 is correct, but the conclusion 1 is not. 2 is correct and 1 is also correct. Okay, first is the answer. A compound decolorizes esterified potassium manganate. What could be the compound? A compound decolorizes esterified potassium manganate. What could this compound be? Magnesium chloride, iron chloride, and ethanol. Decolorizes. Yes, actually, esterified potassium manganate. It is the oxidizing agent. Oxidizing agent, and it provides what it provides atomic oxygen. Okay, so atomic oxygen when provided, so magnesium chloride, this bond is stronger, but in this case iron may react with the oxygen, so that's why it is also oxidized, Fe2O or FeO. So this can be oxidized. Okay, but this will never be oxidized. And ethanol, it is oxidized. It converts into the ethanoic acid. Okay, from the organic chemistry. So option 2 and 3 are correct. Nitrogen reacts with oxygen in an equilibrium reaction. You have seen this. Okay, when the reaction is at equilibrium, which statement is correct? What it shows? Plus means this is a endothermic reaction, means heat is added. The concentration of nitrogen present will change with the time. At equilibrium, concentration will not change. Okay. The forward and backward reaction are taking place at the same rate. Yes. At equilibrium, both forward and reverse reaction takes place at the same temperature. Forward reaction releases heat energy. No. It is in the forward reaction the energy has to be taken. It's endothermic, not exothermic. There are more molecules on the left hand side of the equation than on the right. No, number of molecules are equal. One molecule here, one here. It becomes 2 and 2. Number of moles are equal in the balance equation. A solution W has the following properties. When added in the excess to the solid ammonium chloride, a gas is given out that turns the damp red litmus paper blue. When the red is turned blue, so it means there is only one gas, which is the ammonia. It's the base, it turns the red litmus paper blue. So which is added? Actually, you must know that when ammonium chloride solution is added, is reacted with the alkali, strong alkali like NaOH. Okay, so displacement of ammonia takes place. How? NaCl will be formed, Na and Cl. OH with the H, H2O will be formed, plus NH3 gas will be released. So it means with a strong alkali. Strong acids, no. Strong base, yes. Weak acid, no. Weak base, no. The pure lead sulfate is prepared by mixing two substances X and Y. When the reaction is complete, the mixture is filtered, lead sulfate is obtained. Lead sulfate is prepared by mixing two. So lead sulfate, PbSO4. We must know that lead sulfate is insoluble or soluble. It is insoluble. Only potassium sulfate, ammonium sulfate, and the one more sulfate and sodium sulfate. Okay, these are soluble. Other are sulfates are insoluble. Okay, two and two are mixed. Okay, X and Y. So lead sulfate is found, which is the precipitate. So when we filter it, it will be as residue, and other salt solution, which is soluble in the water, becomes a filtrate. Okay, which row shows the best way to prepare the pure lead sulfate? Lead nitrate and the aqueous sodium sulfate. Lead nitrate, sodium sulfate. So crystallize the filter. Actually, in this case, what we get, crystallize the filtrate, not crystallize the filtrate, because filtrate will never be the lead sulfate. Okay, lead sulfate will be residue. Whenever they say that crystallize the filtrate, it means basically they are saying that lead sulfate is soluble. Okay, now we have left with the two options: aqueous lead nitrate and aqueous sodium sulfate. Wash and dry the residue. Aqueous lead nitrate, PbNO3 twice, and sodium sulfate. Wash and dry the residue. It's okay. Next is solid lead carbonate and sulfuric acid. Actually, in this way, you will see I write equation for both of these. Okay, because lead sulfate is insoluble, so it will not be filtered. So that's why we don't need to crystallize the filtrate. Okay, so that's why these two options are incorrect. Let me tell you, lead nitrate, PbNO3 twice, plus aqueous sodium sulfate, Na2SO4. So PbSO4 will be formed insoluble, so 2NaNO3. So lead sulfate, PbSO4, you can see this one. So this seems good, means the filtrate will be sodium nitrate, and this will be residue. We'll wash it and dry the residue. Okay, it's okay. Now let's see the second way of preparing. That is the sodium lead carbonate. So solid lead carbonate, PbCO3 plus sulfuric acid, H2SO4. What will be formed? Lead sulfate plus H2O plus CO2. Okay, but here the gas is released and three products are formed. Okay, the second thing that uh, we cannot mix properly lead carbonate. Okay, so this is the best way. You can wash and dry the residue. We can wash and dry the residue. So option B is the correct. Okay, here the gas is also produced, so it seems a bit hard process. What's the question? Which row shows the best way to prepare? Means all of these processes in which are prepared, but which is the best? So best is the second one. What are the percentages of methyl nitrogen in ammonium nitrate and calcium nitrate? Let's find out. Ammonium nitrate, NH4NO3. Nitrogen 14 plus 4 for 4 nitrogen, 14 plus 16 multiplied by 3, it becomes 48. So total mass, what will be its total mass? 1, total mass is 80. It becomes 80. And out of 80, how many is a gram of nitrogen? 14 plus 14, 28. 28 divided by 80 multiplied by 100. What we get? We get here percentage which is equal to 17%. Okay. And the next is ammonium nitrate, NH4NO3. 14 plus 4 plus for nitrogen 14 and for 3 oxygen 48. Sorry, not nitrogen. We have done this one. The next one is calcium nitrate. Okay. CaNO3 twice. Calcium has 40. 2 nitrogen are there. So 14 multiplied to 28 plus 3 twos are 6. 6 oxygen are there. And for 1, 16. 16 multiplied 6. It becomes 96. Okay. So what will be the mass which we get over here? That is the 164. Out of 164, nitrogen has 28. So 28 divided by 164 multiplied by 100. What do you get? It becomes 35. This is 35, sorry. And it becomes 17%, okay? So calcium nitrate has 17%. This is correct. But this is not correct, okay? And then ammonium nitrate has 35. This is okay, but this is not correct. This is not correct. This is not correct. This is correct. So option D is okay. You need to have calculator to calculate these small mathematical calculations. The diagram shows 3 steps in the manufacture of sulfuric acid. You can see that sulfur reacts with in first step, then sulfur dioxide is formed definitely with oxygen. Sulfur dioxide reacts with oxygen to form the sulfur trioxide, and then next sulfuric acid. In which step is catalyst used? Yes. When sulfur dioxide is converted to the sulfur trioxide, here the catalyst is used in Q. Here in Q, when we are converting sulfur dioxide into the vanadium pentoxide, you would have seen 2SO2 plus O2 raised to 2SO3 and V2O5. Vanadium pentoxide is used. This statement about the elements in the periodic table is correct. An atom of potassium K has more protons than an atom of argon. Potassium has 19 and argon has 20. No. Elements in the same period have the similar chemical properties. In the same period, they don't have similar. In the same group, they have similar chemical properties. Incorrect. Elements that are non-metals form only covalent bond with other elements. They form covalent bond with the non-metals. Okay. Sorry, the first one is argon. Let's see. What's the answer? Argon has atomic number 18 and potassium has 19. So number of protons are higher in the potassium. It's okay. So they form only covalent bond? No, they form ionic bond as well. Okay, with on descending group from 1 to 2, the cesium, the metal become less reactive. No, reactivity increases due to increase of the size. It becomes easy for the metals to release electrons, and this way the reactivity increases instead of decreasing. Option A is correct. Okay, argon has 18 protons, potassium has 19 protons. Okay. The position of 4 elements are shown in the outline of part of the periodic table. Which element is a solid non-metal at room temperature? Fluorine, chlorine, bromine, iodine. Iodine. Okay, this is a halogen, no? 7th A. Okay, fluorine, chlorine, bromine. We can stop. Bromine, iodine. Astatine is here, but this is iodine. Iodine is solid. Okay, he is not. This is something else is aluminium. Okay, Baba aluminium. This is the metal solid. This is oxygen. O society to oxygen. This is fluorine, chlorine. This is chlorine. Bromine, iodine. Iodine is the solid. Chlorine is also a gas. Okay. What is not typical property of transition elements? They form colored compounds, it's okay. They have high melting point, it's okay. They have low density, no. They have high densities. They have variable oxidation state, it's okay. These are properties are there, okay. But is asking which is not typical property. So this is not a typical property, so that's why this is the answer. Brass is an alloy. Which statement about the brass is correct? It contains C of electrons. It's okay, of course. It contains C of electrons because this is a physical mixture. Physical, you can say, mixing of the metals. Alloy is a physical mixing. Okay, now both metals combine. Okay, copper and zinc, I think. So both metals combine to form the brass, beetle. It contains positive and negative ions. How negative ions are there? No, it's not an ionic compound. It is a compound of the metal and non-metal. No, there is no metal and non-metal. Both are metals. It's compound of two or more metals. It's not even the compound. It's not the compound. This is the mixture. Okay, brass and alloy. Alloy is the physical, is the mixture. They don't react chemically. Okay, this is not compound. Compound is formed by the chemical reaction. Okay, in the fixed ratio by mass. So these are not compounds. Okay, so option A is the only which is the correct. Okay. Question number 30. Which statement about the reaction of the some metals and metal compounds are correct? Copper reacts with a dilute. Which statement about the reactions of some metal with metal compounds is correct? Metal with the metal compound. Okay. So copper reacts with a dilute hydrochloric acid. Hydrochloric acid, HCl, it is not metal compound. Both are non-metals. This is metal, but this is not metal compound. This is covalent compound with which is due to non-metals. Hydrogen is non-metal, chlorine is also non-metal. Sodium oxide Na2O. This is reduced to the sodium metal by heating with the carbon. Carbon is non-metal. Reaction of some metal with the metal compounds. This is metal compound, it's okay, but this is non-metal. Incorrect. Zinc carbonate ZnCO3 is more thermostable than the sodium carbonate. It's comparing, they are not being reacted. Okay, this is not about the reaction of some metal with the metal compounds. It's just comparing that zinc carbonate is more stable than the sodium carbonate Na2CO3. Okay, there is no any type of reaction of the metal with the metal compound. Zinc displaces copper from the copper sulfate. Zinc displaces copper from the copper sulfate. This is the metal compound and this is the metal. Okay, and it can displace the copper from here to form the to what will be next. That is the next thing, but zinc can displace copper because it is more reactive. So here is the metal which is reacting with the metal compound. Okay, D is the correct option. Which metal is used in galvanizing of iron? Is used calcium? No. Copper? No. Lead? No. Then here zinc is used. Okay. Zinc is used for the galvanizing. A thin layer of zinc metal is formed over the iron to protect it from the rusting. It's called galvanizing. Iron is obtained in the blast furnace from the ore hematite Fe2O3. Which process takes place in the blast furnace? Fe2O3, basically it reacts with the 3 carbon monoxide to form 2Fe plus 3CO2. Calcium carbonate is used to remove acidic impurities. It's okay. Coke is reduced to carbon dioxide. It's also okay. What we are looking for? Calcium carbonate is used to remove acidic impurities. Means calcium carbonate is a CaCO3. Actually, we don't have to go into details of this. Okay, this is just about the hematite. Okay, we have written. It's okay, no issue. Which process takes place in the blast? Calcium carbonate is converted into the calcium oxide plus carbon dioxide. So this is base and it is used to remove the acidic impurities. This is correct. Coke is reduced to carbon dioxide. Not. Coke means the carbon. It is oxidized, not reduced. Incorrect. Hematite is oxidized by carbon dioxide, not oxidized. Removal of oxygen is not oxidation, it is a reduction. Hematite is reduced by carbon dioxide. Okay. Hematite undergoes thermal decomposition. No, there is no decomposition. It goes the reduction reaction. Okay. Option A is correct. Aluminium is a group 3 element. It is extracted from the ore by electrolysis. The position of aluminium in the periodic table indicates that its aqueous ion is likely to be colored or colorless. Colorless. Reason because aluminium is not a transition element. Okay, aluminum is not transition, so it can never be colored. It will be colorless. Its method of extraction indicates that aluminum is in the reactivity series high or low. It's higher in the reactivity series. That's why it is not reduced by the carbon or hydrogen. Okay, so it is aluminum is extracted by electrolysis because in the reactivity series it's at very high position. Okay, so it's colorless and its reactivity is also high. Reactivity is low, so it is incorrect. Due to its high reactivity, it cannot be separated by the carbon or any other hydrogen. Which pair of gases are both non-acidic? Ammonia, basic, methane. It's not acidic. Okay, carbon dioxide is acidic and ammonia is basic. Incorrect. Methane is whatever is basic, but when you see here nitrogen dioxide, so nitrogen dioxide is acidic. Okay, that's why it causes the acid rain. Okay, and carbon dioxide when it takes to the water, it forms normal water forms a carbonic acid. Nitrogen dioxide and carbon dioxide, these both are acidic. So non-acidic is only ammonia and methane. Ammonia is confirmed that it's base, and it is also not acidic. Means it can be base, but it's not. But acidic. It's not acidic at all. Which term correctly describes the conversion of seawater into drinkable water? Seawater, what it contains? Seawater contains actually it is saline. Saline means namkeen, means it is salty. So removal of salt is called desalination. Not chlorination. It is used for killing the bacteria from the swimming pool. Filtration to remove the insoluble solid particles. Neutralization, reaction of acid with the base to form the salt and water. Okay, so this is desalination. Which formula represents alkane? Alkane, what is alkane? CnH2n plus 2. Number of hydrogen has to be 2 more than the twice of the number of carbon atoms. Carbon 1, hydrogen 33, carbon 31, and there is only 2 more than, not 2 more than, 2 more than the twice. 31 and 60. No, 31 62, it is only twice, so it is twice doesn't mean that this is alkane. 31 and 64, yes, 31 is double is 62 and plus 2 it becomes 64. Z is a compound that can be formed as the only other product when the alkane C8H18 is cracked to be to produce butane can be formed as the only product when alkane C8H18 is cracked to produce butane. When it is cracked to form the butane, alkane is cracked to the butane. So next has to be butene. Okay, one is butane, then other has to be butene. Okay, that's not correct. Z is compound that decolorize the bromine water. Sorry, these are the statements. Z is compound that can be formed as the only other product when alkane C8H18 is cracked to produce butane. When the butane is formed, so Z is also produced with it. So it means if one butane is formed, butane means 4 carbon. Okay, you know that when alkane is cracked, so small alkane is formed with alkene or hydrogen. So if butane is formed, okay, from the alkane, so next will be the butene. Butane and butane will form the this octane. Okay, C8. So butene, okay, decolorize the bromine water, so it confirms that it should have butene. Actually it has carbon carbon double bond. Okay, so that's why it's definitely it decolorizes bromine water. I'm writing it C8H18. Its cracking takes place C4H10. So what is the next? C4HO8. This is butene having carbon carbon double bond. So butene, I'm saying the second thing, it confirms this product that it decolorize the bromine water. So CnH2 definitely unsaturated compounds decolorize the bromine water. Okay, and has a branch chain structure. When it says the branch chain, so let's see branch chain and the butene. Okay, so 4 carbon has to be there but branched, 3 carbon are there, it's not. 1 2 3 4 4 carbons are there but there is no, it is butane, not the butene. Incorrect. 1 2 3 3 carbon are there, no. 1 2 3 and 4 4 carbons are there and a double bond as well. Now you can see its formula: 1 2 4 carbon C4 and H8, 3 and 3 6 and 2 8. Option D is correct. It is the compound which is produced the other than the butane. One is the butane. This is the butane, okay, which is alkane. The second is the butene, which is alkene. Okay, this is the compound, and it decolorizes because it is unsaturated. It decolorizes the bromine water. And third thing, it has a branch chain, so definitely it has the branch chain. So D is the option correct. A carboxylic acid of the carboxylic acid of molecular formula C4H8 and O2 reacts with the alcohol to form the molecular formula C3H8 and O to form an ester. Carboxylic acid of molecular mass C4H8 and O2 reacts with an alcohol, okay, of molecular formula. The alcohol has the molecular formula this one, and the carboxylic acid formula has this one. Okay, carboxylic acid, and this is the formula of alcohol to form an ester. Okay, let me write here C4. This is carboxylic acid. I'm writing as C4. 1 2 3 4. Okay, this is carboxylic acid. So C double bond oxygen and OH. Rest number of valency will be satisfied. One next and one previous bond. So 2 hydrogen will be here. Okay, 2 hydrogen will be here to balance its valency. 4 valency 3. Next is C3 and H4O. This is alcohol. Alcohol, what we know about alcohol? Alcohol, three carbon are there. One, two, three. It will be CH3. It will be CH2. It will have OH. One and one. This will be H2. So H from here and OH from here will react to form the H2O. What will be left to CH3, CH2, CH2, C double bond oxygen, and its bond will be there. This bond will be with the next oxygen. Okay, this next oxygen, its bond is broken with the hydrogen, so its bond will be there with the CH2, CH2 and CH3. Means with oxygen there has to be 3 carbon and then here 4. 1 2 3 4 not possible. 1 2 3 it's okay, and here has to 4. 1 2 3 4 it's okay. 1 2 3 4 it's okay. 1 2 3 4 here it cannot be 4, it has to be 3. 1 2 3 it's okay. 3 like, but here is only 3, here has to be 4. So 4 carbon and 3 carbon here and this, so it becomes propyl butanoate. Okay, from propane it comes propyl butanoate. Some properties of compound J are listed. It reacts with the potassium carbonate to produce carbon dioxide. It has to be acid, that's why it's producing carbon dioxide. You know that potassium carbonate, which acid plus carbonate. Okay, what is formed? Salt plus water plus carbon dioxide. Okay, let's see what it says. It reacts with the ethanol to produce a sweetening smell. Sweetening smell of the, it is feature of ester, and ester is made up of the alcohol plus carboxylic acid. Am I right? Okay, it's made and the water is removed. In this way is the, okay, and it has the sweet smelling. Okay, artificial flavor, it can be used in the artificial flavors. So it has to be acid. With alcohol, the second product has to be acid, and it reacts with the sodium hydroxide to produce salt. Definitely when it is acid, so it will react with the sodium hydroxide, which is base. Acid plus base react to form salt plus water. So it means from all these things it is confirming that this is the acid. Ethanoic acid, yes, because this is not that one acid which is the sulfuric acid or nitric acid. It has to be organic acid because it forms the ester as well. Ethanoic acid, yes, it has to be. Ethanol, no, it can never be. Ethyl ethanoate, this is the ester, it is not possible. Ethyl methanol, this is also ester, not possible. Here's the option. Which partial structure represents the nylon? What is the nylon? Nylon is let me tell you just one thing, that nylon is not polyester. Okay, it's diamine dioic acid. Dioic acid plus diamine. Dioic acid, double bond oxygen, OH. Okay, here will be in the same double bond oxygen and OH. And diamine means here will be nitrogen and hydrogen. This one hydrogen, nitrogen, and this one hydrogen, and this one. So OH from here and H from here will react from H2O. Diamine and dioic acid, okay, will react to form. You will see which type of bonding will be there. Just let me tell you the one type of bonding, carbon double bond oxygen. This will be attached to the nitrogen and hydrogen. It is also called polyamide because many amide bonds. This is the amide linkage. Okay. This is the nitrogen. It will also form the bond in the same way next to the next carbon if there when there is. So this is polyester. This is not possible. Carbon double bond oxygen, nitrogen, hydrogen. It's okay. but diazoic acid just amine, then this one amine. It's okay. This is and nitrogen. What make it different from each other? This shows actually four cardinal means carbon. Okay, four carbons has to be there. It's not possible. This is polyester. This is not possible. This is the correct option. Okay, because these four carbon shows that there are four carbons. Okay, cyclic. Okay, but here is this shows that there is no carbon. Okay, this is incorrect. This is incorrect. This is polyester, and this is the only which we call nylon. Okay, polyamide as well. Thanks for watching this lecture.